This is question number 5 of homework 5. A project that provides annual cash flows of $16,900 for 8 years costs $75,000 today. What is the NPV for the project if the required return is 7%? So there are at least 2 ways to get the NPV for this project. One way is to simply if I use Excel to solve this problem, I can put down annual cash flows. So we have 8 years. So stop here. And year 0, that's the current cash outlay. That's the cost for the project, $75,000. And year 1 through year 8, that's $16,900. And this is the same. So we have the list for the annual cash flows and the discount rate. This rate is 7%. 7%. So NPV, you can use the NPV function in Excel equals NPV. And if you look at, let me make this bigger so you can see this more clearly. So this equals NPV. The first argument is rate. That's the discount rate, 7% here. And then we have the values 1, values 2, values 3. A key to use this NPV function in Excel is to remember that the value by here refers to the cash flow of year 1, not year 0. The NPV function actually doesn't include the current cash flow. So you have to manually include that part after you have done this NPV calculation in Excel. So just starting from year 1, pull all the way down to year 8, and that's actually the present value of all future cash flows. NPV is just the net of that value, that present value, by the initial cash outlay, which is $75,000. So I just minus the initial cash outlay, and that is my NPV. So I have to look at the rounding requirement. Do not round intermediate calculations, and I think that's the huge benefit of using Excel. That can help you to avoid using the intermediate calculations and round your answer to 2 decimal places, and that's what we did. So you don't have to format the cell. Otherwise, you have to change the format of the cell to be consistent with the rounding requirement. So NPV is I should put that number here, 25914.94. And so that's one way. I said there are at least 2 ways to get this number. The other way actually is to use the present value function as we learned in session 3. Yes, so it's a present value. The first argument is still the rate here, and actually we are doing a present value of an annuity, because starting from year 1, every year the cash flow is the same. So it consists of a annuity. So it's the present. We use the present value of an annuity formula to figure out this present value. And the NPER, the second argument here, is the number of payments. So here the first payment starts from year 1 and ends at year 8. So we have 8 payments, and this PMT is the payment. So the rule here is that if you put this as a positive number and the fourth argument, the future value, that refers to the par value. In this case, we don't have a future value, so we can just put that as 0. But this payment rule here is if you put a positive payment, then you'll get a negative present value. So if we want a positive present value, we have to put this payment as a negative number. So that's the, and finally, the future value, that's 0. So that's only the present value of all future cash flows, present value of annuity in this case. And then we also have to subtract the initial cash outlay. And that's, you can see both way, we get exactly the same answer, right? So that's the NPV. Continue at a required return of 7% should the firm accept this project. So in this case, we just need to change this. Oh, actually, it's the same. So because NPV is positive, so we should accept, right? So that's the very simple. And continue, what is the NPV for the project if the required return is 19%? NPV for the project if the required return is 19%. So in this case, we just need to change this 7% to 19%. And then you can see the number NPV will change. And now it becomes a negative number. And that makes sense, right? Because the higher the discount rate, the lower the present value of all future cash flows. And then the present value will become smaller. Hence, if you subtract the same initial cash outlay, that will likely make this number to be NPV to be negative. And that's what happened here. So NPV in this case is a negative number. So also look at the rounding requirement. Negative amount should be indicated by a minus sign. Do not round intermediate calculations and round your answer to 2 decimal places. So 8171.22. And at a required return of 19%, should the firm accept this project? In this case, because NPV is negative, so the firm should reject this project. So the final part of this question, at what discount rate would you be indifferent between accepting the project and rejecting it? Looking at this sentence, what is it asking? So that's the most important thing to figure out. If a firm is indifferent between accepting and rejecting a project, in terms of NPV, what does that say about the value of NPV? If NPV is positive, then the firm should accept this project. And if NPV is negative, then the firm should reject this project. So the only situation that the firm is indifferent between accepting and rejecting the project is when NPV is exactly 0. But we know that when the NPV is exactly 0, the discount rate in that case is what the IRR, internal rate of return, means. So this sentence simply tells us asks us to calculate the IRR for the project. So we can use the IRR function in Excel to do that. The difference between the IRR function and the NPV function is that the IRR function actually, the first argument is the initial cash outlay. That's unlike the NPV, because we said NPV, the first argument, the first cash flow is the cash flow at year 1. But for the IRR function, the first cash flow actually is the initial cash outlay. So we need, it's better for us to put a negative numbers just to consider the sign. So far we haven't done that, but for the if you do that, actually you have to use plus. Same thing here, plus. plus. So now after incorporating the signs on the cash flows, we can use the IRR function in Excel, starting from year zero's cash flow and pull all the way down to the last cash flow, which is year 8. And that's the values. That's what the values here mean. And then the guess. Guess here means that the starting value for the IRR, because the way Excel gets the IRR is also by trial and error. So this guess tells Excel what number to try first, and after Excel calculate the NPV based on that discount rate, based on whether the NPV is positive or negative, then Excel can choose the next guess number for the discount rate until finally the NPV is 0, and that corresponding the corresponding discount rate in that case is the IRR. But in this case, we know that there is only one IRR because if you have learned, which you should, Finance 505. Actually, this is Finance 505. So in Finance 505, we talk about when the cash flow is expected to change the sign, and the number of IRRs is the number of times that the cash flow change signs. So in this case, the cash flow changes from negative to positive, so only once. So there's only one possible IRR. So in that case, we actually don't need that guess number because for any starting value of the discount rate, Excel can always find the right IRR. But then you have to notice the rounding requirement. Do not round intermediate calculations. Enter your answer as a percent rounded to 2 decimal places. So this is percent, but only rounded with no decimal places. So we have to change the format cells and use percentage, and then keep 2 decimal places. 15.34. So now let's check our work. So looks like we got everything right. Okay,